last part of this chapter is convexity. Now, the duration generally show the, good things. The interest rate risk, degree of the interest rate risk. There's a key problem here. Let's see this graph. So this is actual price change. You know that the relation between the price changes, the bond price changes, and the yield changes is convex curve. You have curvature like this, right? Now the duration, actually, if you look at the duration is simply, so let's look at the modified duration. It's linear function. So it does not capture this gap. So in fact, these changes only capture the linear factor, like the one that, so this actually measures the slope when interest rate remains the same. The slope keeps changing actually because of this curvature. So we need to capture another factors, so-called convexity, to find the exact changes. So convexity is a little complicated to calculate because there is a formula here, right? So if you look at the convexity formula, we don't have any slides, so I'm going to show it. So convexity formula is actually kind of very complicated. So the convexity formula is I never asked you calculate convexity before, but I probably there may be some Excel spreadsheet we have here, so you can actually get it. So this spreadsheet actually show the convexity formula. So I'm going to show it actually. So this is the spreadsheet about the convexity. Basically, convexity formula is so it's basically, I'm going to write it down here. So the convexity formula is a little complicated, you know. So convexity formula is, I'm going to show it actually in the web. So let's look at these. Yeah. See, this is convexity formula. So convexity is 1 over p times 1 plus y squared, and sum of cash flow t divided by 1 plus y to the t times t squared plus t, which looks pretty complicated, right? So we basically have to do step 1 by 1 to get the convexity. So this Excel spreadsheet actually show that this is 3%, 4.5%, so the amount of coupon is $3. $100 cube value, 10-year price is 88.13. Then the cash flow is at $3 for 9 years, right? And the last year, $100 per value and $3 coupon. Calculate the price of the cash, the present value of each cash flow, add them up, then that will be the price, right? And calculate the t plus t squared. So that's the t is time, 1 plus 1 squared, 2 plus 2 squared to the 10th. And then times present value of the cash flow and add them up. And then you basically also divide by price times 1 plus y to square. Then you're going to get convexity. So I usually don't require you to calculate the convexity itself. This is convexity. If the convexity is high, it means that you are basically more high. The conventure is higher, like a, so conventure is more curved basically. So if the convexity is higher, it means that it's more curved, more curved. Okay. So I'll pull up the slide here. Try to pull up it. Ooh. It takes time. So let's pull up from, just hold on please a little bit, because it doesn't work right now. So let's look at the slide here actually. Okay. So impact convexity can be also, so this first factor is duration factor, right? Duration factor. And the second factor is convexity factor. It's a half times convexity times delta y squared. Delta y is the interest rate changes. So if you have more convex, which means your curve is more curved, which means it's good, great. Because if the curve is more curved, then it actually have so if it is more curved, then what it means that curvature is more curved, like this. So what it means you get more higher price actually. So people like convexity. Again, flatter and more convex one is like this. And you see the more convexity one, price change is greater, like, right? So greater price increases, small price decreases when interest rate fluctuates by large amounts. That's why we like convexity. So Now, so let's see this example. The bond in figure 11.5, 30-year maturity, 8% coupon sells at the initial yield to maturity 8% because the coupon rate equals to, see, coupon rate is yield apart is $1,000 same price, right? The modified duration of the bond at its initial yield is 11.26 years, and the convexity is the 212.4. Now, if you just look at so suppose the interest rate changes by 2% point, then if you use this delta price times T equals to the modified duration times delta Y, then you see the negative 22.52% changes, but it's not everything because we ignore the convexity. Now, including the convexity and using the formula we have, then it's actually decreased a little bit, 18.27% decreases. So it means that this is duration one, this is convexity one, right? So when interest rate rise, the price decreases, but not this much. We have some compensation from this curve. So convexity is good things, actually. Now, if, so 2% point, it's very different, right? But if it is very closely, like small changes, such as 0.1%, say, then using duration negative 1.126%, but using convexity negative 1.115%, very small. I mean, in this case, the duration rule fine because the error is very small. But if the change is large, then you surely need to use the convexity, not only duration. Now, we have so far we see the passive bond management. There's some active bond management too, using the swap. I'm going to skip this part, but just to read it so that you can get some sense about the active bond management. Basically, they try to find the undervalued bond. So, for example, there's this so-called the horizon analysis. A 20-year maturity bond with a 10% coupon rate, if it is paid annually, currently sells at YTM 9%. The portfolio manager with 2-year horizon need to forecast total return on the bond over the coming 2 years. So these cases, in passive strategy, you don't really need to forecast it, but in active strategy, you really need to forecast it because the interest rate may changes too. So the current price is $1,091.29 because you have 20-year 9% yield to maturity and the 10% coupon rate, right? Now in 2 years, the bond will have 18-year maturity, so it becomes 18-year bonds. And if the interest rate drops to 8%, it means that your price increases. So you basically get some capital gains because your new price is 18-year left, 8% yield, and $100 coupon, $1,187.44. And then also you get some interest and reinvest it, right? So $100 interest for 2 years, and first $100 reinvest is at what, 7%, right? So $207. So your 2-year return is $207 from the interest, and the capital gain is the price you have and your price you purchase, and then divided by your purchase price, then 27.8% is holding period returns, right? Now you have holding period return 27.8% for 2 years, which means you can actually get the year returns, compound returns, by 1 plus 27.8% to the 1 over 2, because it's a 2 years, minus 1, which is 13%, is the annualized rate of return for 2 years. This is called the horizon analysis. So fixed income investment strategy, they try to find, for active managers, they try to find the undervalued asset. And undervalued asset, basically, you need to get right projections. The problem is the third one is very important. Interest rate movements are extremely hard to predict. We never know that we have this low interest rate, because of some factors, right? Like such as the coronavirus, we are experiencing like in 2020, and it's basically give us that, this shock actually is not predicted, so it's extremely hard. At time to time, the market can wipe out the all profit of intra-market analysis. So the fixed income analysis, let's say the manager's speech from Bernstein. If we set duration of our portfolio level equal to the index and never allow them to vary, this would imply that we are perpetually neutral in the direction of interest rate, right? However, we believe the utilization of this forecast will add value, and therefore we incorporate our economic forecast into the bond management process by altering the duration of our portfolio. However, to prevent fixed income performance from being dominated by accuracy of just a single aspect of our research effort, we limit the degree to which we are willing to alter our interest rate exposure. Under the vast majority of the circumstances, we will not permit the duration of our portfolio to differ from that of the Barclay index by more than 1 year, which means that it's really it's a little probably difficult to understand. But one thing, just interest rate movement is extremely hard to predict. It's very hard to find, to get a minimum return from the bond research, So even though we may get some small annual returns, sometimes it's not a good deal because the effort is more expensive. Okay. So it depends on you. Sometimes it's the bond fixed income strategies, the bond investment strategy may be active or passive, maybe mixed, but active strategy still is not very easy to, it's kind of hard to pursue for many investors. Okay, so this is end of the chapter 11. Thank you. And one thing you have to remember is, you don't have to really focus on these kinds of active one, but you need to know the duration, convexity, and the immunization pretty thoroughly, okay? So again, this is it for chapter 11.